Hi everyone, my name is Amy.
And I'm Johnny.
And this is our first STEM coding video. I'm a PhD student at West Virginia University, and my research is in astronomy. Specifically, I'm looking at how hydrogen flows into galaxies due to the galaxy's gravitational pull, and that hydrogen is potentially fueling star formation in that galaxy. And this is all happening in the nearby universe.
I'm a postdoc here at The Ohio State University, and I study galaxies that are very diffuse, which makes them very hard to find. And in particular, I study these galaxies in detail to try to figure out what they can teach us about how galaxies form and evolve.
The first activity that we're going to do, this is called the Slingshot with Gravity activity. We are going to look at two astronomical bodies. So these types of bodies can be a black hole that maybe a neutron star is orbiting around. It could be a star that a planet is orbiting around. Can you think of others?
It could be a comet going around the sun, or a satellite going around the Earth.
Right, so all of these are examples of two bodies where one body is orbiting a much more massive body. And what we're going to look at first is an interaction, not an interaction.
An interactive
program.
Yes, so we're going to strip the problem down to start with, because in the end we want to have a blob orbiting a much bigger blob, right? But let's just start with having a blob that can be any mass you want. Say it's a planet or a star or a rock. Right, but we're not going to have any forces acting on this body.
So no gravity.
No gravity.
Yeah.
So here's the blob right here with this little point. And what the program allows you to do is you can touch it if you have a touch screen, or you can use your mouse if you don't. It allows you to drag like a slingshot. And you can, the longer you drag it, that's going to be the larger your velocity vector will be when you let it go. So if I drag it like this and let it go, like a slingshot, there it goes. And if I drag it, make a longer arrow, there it goes even faster. Now the thing to notice, so we have no forces acting on it once you let it go. And so what Newton tells us is that if a body doesn't have any forces acting upon it, it'll just keep moving as it's moving in a straight line. And that's exactly what we see here. Another way to say that is that no matter how I throw this object, I can get creative and have fun like this, I can never make it curve. Once I let it go, it's going to keep going in that direction in a straight line. And in this exercise, what we're going to do is we're going to show you how to adapt this code and put in a blob that has gravity that will influence the motion of this object.
So let's take a look at that code.
Yes, let's take a look. So, yes.
All right, so I'll get out of the way of the code here. The first thing that you see up at the top here, these are our initial parameters. So our x and y, this is just going to be an initial position for our blob.
Here's our blob.
The velocity here, initially our x velocity, the direction in the, or the velocity in the x direction is 0, and the velocity in the y direction is 20. So if you were to just push play up here at the top.
Up here at the top. Let's do that.
Then you would see that it's going to move in the y direction with a magnitude of 20.
And the position started at 525,
right.
250.
Right.
Yep.
And you can see that our initial parameters here show us that the delta Vx and delta Vy, that's our acceleration, and that's 0 initially.
Right.
Okay, so the next thing we're going to do is we're going to step through this draw function here. This draw function is important because this is what the computer, after it has read off all of these initial parameters here, this is where all the action happens, and the computer is going to read this draw function line by line, and it's going to do this 60 times per second. So it's very fast, and this is how you make the blob move. So actually, let's step through this line by line as well. The first thing we're going to do here is we're going to update the velocities. The Vx and the Vy there, you're dealing with delta Vx and delta Vy there. And the first time, it's going to read 0, right? Because we've already set this to be 0. And so for the first thing here, there's nothing that's going to change about the velocities. There's no updating happening. The second thing the computer is going to read here is updating the location. So we take the Vx and the Vy that we've just updated, and we plug it into this here, and it updates that location 60 times per second again. And then down here, the velocity here is unchanged. So again, this delta Vx and delta Vy is 0. So no change in velocity there. The lower part here, this display, this is what is happening kind of in real time. It clears the screen and it redraws the display, so that's how we're going to see it move around. And then the last thing here is we want to add another thing to our display, so we're going to actually add another object because we need two objects to have some kind of orbit. What kind of object do you think we should add? A black hole?
A black hole? We could add a black hole.
We could add a star.
A star might be easier.
Let's do a star.
A star.
Let's do a star. Okay, so if we go back to our activity.
Let's do that. There you go.
What we need to do is we need to add a sun.
We're going to add a sun.
We've chosen a star. So here we have the sun X position and the sun's Y position. And we're going to copy that and then paste it onto our code.
Now the sun's not going to move, right? Its position is going to be fixed?
That's correct. We are going to apply the force of gravity, but what we don't want to happen in this particular case, for simplicity, would be we don't want the planet to be pulling on the sun. We just want the sun to be pulling on the planet. So the sun's not actually going to be moving around like it would. It would do a little bit of a wobble normally, but for simplicity, we'll skip that part.
Okay.
All right.
We've added its position.
We've added the position. The next thing we want to do is this draw sun function. So let's copy that to our code. Okay. And do you want to tell us what the draw sun function does, Johnny?
So the draw sun is just like our draw blob function, except it's going to draw, instead of our little circle here, which is our planet, it's going to draw a giant sun. Let's try it.
So if we paste that into our code, we just want to Control V that there, and we have a draw sun.
See, there we go, and it's using the positions that we put at the top of our code for the sun, right here. Okay, let's see. Let's just see if that works. Oh, look at that.
Oh, and there we have our sun.
Yeah.
Okay, so we still don't have any gravity. All we have is an object.
So we need gravity.
We need to give this object mass, and we need to give it a gravitational constant. Right. Maybe you could actually talk about why we need those things.
Okay.
So let's switch over to drawing on the board here.
Okay.
And we'll talk about the force of gravity.
Sounds like a good plan.